Hello everyone, my name is Stefan Hexelmann and I want to share some work with you today that came up during development of a machine learning model for routine healthcare. And in this project, we work with the so-called generalized additive models with interactions. You might have heard about these models already from a widely recognized paper by Rich Caruana et al., where they trained these models to predict the risk of dying from pneumonia. Here on the left side, you can see a learned risk function taken from their paper. And you can see that it associates a history of asthma with a lower risk of dying from pneumonia. So that's against common medical knowledge, so you probably want to exclude this from your final prediction model. While we can probably agree that this risk function here on the left is interpretable, the situation can get much more complex if we move to continuous variables or even interaction terms. Here on the right side, you can see two example risk functions from our paper. Caruana et al. State that these models are intelligible due to these visualizations of risk functions. However, we consider this insufficient to ensure clinical safety. So we asked ourselves, can doctors really interpret risk functions to validate these models for a clinical application? So how do we proceed? We really simulated this clinical validation process. To this end, we trained these models on a Mimic-3 benchmark task. And then we presented the learned risk functions to doctors and really asked them, would you include this risk function for your final prediction model, or would you rather exclude it? So this is what you see here highlighted in red in our evaluation questionnaire. Apart from that, we collected so-called objective factors of interpretability, where we asked doctors to read different function values and to answer statements about important graph properties that we considered essential for understanding. And we collected so-called subjective factors where doctors could rate their certainty to correctly understand a risk function, and they could give written feedback about factors supporting or hindering interpretability. So what are our main results? First, our evaluation suggests that doctors can correctly interpret risk functions and that they also feel confident in doing so. However, we wouldn't generalize interpretability to the whole model class, but instead we think it really depends on the complexity of specific risk functions. We've also observed that participants disagreed on which function should be excluded, so that's really a very personal decision. And we think we emphasize the importance of application-grounded evaluations to assess interpretability. We conclude that generalized additive models with interactions are useful when there is little experience with machine learning. It is necessary to build trust. There are high safety demands, and the data you work with is not very complex. Thank you very much, and hope to see you at the virtual poster session.